Welcome. This is going to be, I guess, the Git workshop for DSCs maybe this year. Maybe we'll do a follow-up one if we want to go into advanced stuff. But the purpose of this workshop, I guess, is to give you all an introduction to Git if you haven't used it. For those of you that may have, I hope that there's some interesting tidbits to take away, some nice tips and tricks to help you along in the future. The other thing is that we're going to be running a Cahoots, which is really cool. So for those of you that do well, you will win a Google Home. So that goes to the top 3. As well, I guess we're also going to be giving out some Uber Eats vouchers. So for 3 of you who are lucky, at the end of this, we're going to give out some Uber Eats vouchers. So hopefully that means 6 lucky people. And for the rest of you, I really hope that you enjoy this workshop and learn something while you're at it. So may I ask for everyone here, who has used Git before and who hasn't? Yeah, I imagine there's a good mixture, because some universities teach Git as part of some of their subjects. Interesting that I learned from Adelaide is that they teach them SVN, which was the most popular version until Git came along. And so we can start talking about that. What I'm going to do is get rid of these stupid Zoom things, and so I can actually see my screen. Fantastic. All right, so I've set up some slides for this, and rather than running it from the site, but if you guys are interested, you can find them right here. So I'll put the link in the chat just so that you have them and you can look at them yourself if you want. And then just because this is a developer's workshop, I'll just run it locally just for the fun of it, just because I can, and I probably might get a slight better performance anyways. It already is running. That's why my computer fans are going off. All right, outside of Zoom running, of course. So let's get started. So what is Git? Firstly, for those of you who haven't used it before, it's basically like it's a software that allows developers, especially in a team setting, to collaborate in their software projects. It could be open source or closed source. It's used in both areas. It was popular originally, or was born out of the open source community, and I guess as we go to the workshop, we might get a bit of a better clue why. But it's really useful. It's also GitHub offers basically sort of like a social network for developers. It's a really good way to get your name out there and start working with people online. So the other cool thing is I added in a dark and light thing for it just to make it extra special. But so this is a co-hosted event. It's Macquarie University, which is myself, University of Adelaide, University of Melbourne and Victoria University. So, and also a big shout out to Google DSC for providing us the Google Minis and the Uber Eats vouchers to give out. So that's really fantastic. And we're always looking for new Google DSC. So if you're interested in running a DSC community, let me know. Let anyone know at your community. As I said, we're always looking for new leads, and we just really want to make this a great program. So yeah, do let us know. Also, one more thing before we get started is the Solutions Challenge is running now, basically. So the Solutions Challenge is really cool. It allows you to essentially, it's a global competition for Google student developers. And the best thing is if you win, you can essentially get to meet with the Google executive board to talk about your software project and stuff like that, which is a very cool opportunity. So I would not miss out on that if possible. So teams of 2 to 4, and the task is to build some kind of project, something useful, of course. So it's really up to you, but just letting you guys know that's on now. So let's get started. A little bit of backstory. So where did Git come from? It came from, obviously it's not just from one guy, but the way that the history works, it ends up with one guy's name tied to a product usually. But Linus Torvalds, the creator of Linux, was also considered the creator of Git. Why did we create Git? Or why did Linus create Git? Well, it turns out that working on the Linux kernel is quite difficult when you have developers all over the world. And it's a huge, complicated piece of software. And using the SVN system, for example, they just weren't getting the performance and the reliability that they needed. And it wasn't really enabling them to work together as developers. So it was created, again, in about 2005. So it's pretty young, actually. And today it's the most popular version control system. But, interestingly, 2010, that's not that long ago. I was in year 10 then. 11.3% of repositories available as open source for using Git. So that's really interesting just to see how quickly Git has become so popular. 2010 is really not that long ago. So it is actually still quite recent, but it seems to have completely aped the industry today. As of 2020, 70% of repositories are using Git these days. So Git versus SVN. Well, I think the main, actually, you guys can see my screen, correct?
Yes.
Yeah, okay, sorry. I usually have that green box around it, just double checking. All right. So, yeah, the big difference between Git and SVN is that Git uses a decentralized architecture. So it's a distributed version control system, whereas VCS was a centralized version control system. With that said, Git has some really great performance. And I think one of the main innovations of Git was not the fact that it's distributed, because you could build a distributed system that ends up being tediously slow. But it works in a way with snapshots and by using pointers and references that it is quite efficient, despite the fact that it's distributed, because often when you distribute something, it leads to performance issues. SVN is very fast, and it's still used in certain settings where they require that kind of speed, maybe extremely large code bases and things like that. So as I said, with that said, the caveats is that it's not really great at handling bigger files compared to something such as SVN. So say, I can't imagine how many software projects I can think of off the top of my head might have a 1 gigabyte file. But if that's something that is in your project, I don't know, maybe you're committing like MP4 files to your project, or like a movie or something. But if that's something that is a requirement, or maybe you want to put entire applications and store it in the version control repository, an application, say like a video game, can be many gigabytes in size. that's not really, Git's not really good for that. On the other hand, it's basically good for everything else. So it handles branching really effectively, which enables the fork and pull flow, which is probably one of the most common ways that developers online, work on open source. And I'll show that later. And also, I'd say one of the real main benefits that Git provides is that it actually, SVN sort of didn't really have the notion of being able to check out and branch and stash changes and offering those kinds of features. So what would happen is, you're a developer working on an SVN repository, and you'd get a call from your boss or something, and there's a big bug. The SDK is not working, and the customers are furious at you, or not at you specifically, but at your company or whatever that you're working for. And so immediately you're working on a new feature, say this awesome new feature, and you're like 80% of the way there, you're almost done. And immediately you have to go and fix this bug. So what do we do with that 80% of that unfinished feature? Well, with Git, we can do things like stash it. We can have branches where we are working on the features and branches where we're working on the bug, and all kinds of different workflows. With SVN, what developers would do is they go, well, shit, okay, I don't want to lose my work. I really don't want to have to do that again. So what I'm going to do is I'm going to push my changes unfinished to the main repository, and then I'll go and fix the bug on the main repository. So there's a whole lot of stuff would often happen on sort of the main repository. And you can imagine that pushing unfinished code to a code base is generally a recipe for disaster. So that's one of the core reasons why Git became so popular. It also has the notion of a staging area. There's other cool things like it's hashed with a SHA-1 checksum, just to prevent malicious code changes. So that's a big thing in software projects these days with security. Developers introducing commits, anonymous developers, for example, introducing commits into big open source projects that lead to vulnerabilities later on deliberately. And that's one way that the SHA-1 helps prevent that from happening. Also, you get a full snapshot of a changed file. And the other awesome thing is that every clone of a Git repository is actually a complete and full copy of another Git repository. And it's open source, so it is pretty awesome. I'm not going to go through this, but if you've never used Git before, these links will help you out, so you can revisit these slides later, and they should give you a bit of an instruction guide. The other thing is signing up for a GitHub account. So we can go to github.com. Obviously, I have an account, but we can just sign up there, and we're all good to go. So with that said, we've got Git set up on our computer, which is right here. So we can do the Git command when it loads. All right, so we can do the Git command, and we can do all kinds of things. And then with most computers, it's actually installed. So with a Mac, it comes with Git, as far as I know. Although I don't remember, I can't tell you that for sure, but it does come with it. So what is GitHub then? So I just talked about Git. It's a version control system, a distributed version control system. And what is GitHub? I mean, it sounds like Git does a fair lot of stuff. It's pretty awesome. So why do we need GitHub? Well, GitHub it's, as I described, it's part sort of social network and part sort of a wrapper for Git that adds a whole lot of functionality on top of it to enable you to collaborate with other developers. You can do things on GitHub such as setting up an organization, and you can, say you've got the Google Solutions Challenge, you can create an organization for the 4 developers you're working with. And then you can specify admin and ownership of the code and different things. you can all have your own branches and you can all work together effectively using an organization. So that's something that GitHub enables. That's really awesome. And we'll see some other cool things soon. So there's also the visual interface. Now I'll walk us through a little bit of that later. There's some really cool features that Git offers that, you know, there's no point. As much I like using a CLI, but sometimes there's just no point because GitHub makes it just that easy to do things. It's like a click of a button, really, really awesome stuff. It also does stuff like continuous integration, which, you know, if you know about it, you know about it. If you don't, you don't. Very complicated. So you can also host sites on GitHub. So this site, in fact, is hosted on GitHub. Obviously, this is running on my machine, but the link I gave you guys, that's actually hosted on GitHub and for free, which is really cool. As I said, you can also set up organizations, and you can do other cool things like being able to transfer ownership of repositories. So you could actually build a software project. Like I think Ben Awad, the YouTuber, did one recently where he built like an Instagram stories clone in VS Code, and then he actually sold the repository. And so in order to do that, he would have transferred the ownership on GitHub, and that's another cool thing you can do with it. So there's a tool as well. Well, there's actually two, technically. There's the GH tool and the Hub tool. And I'm actually kind of confused as to why they both exist, because they're both produced by GitHub, and they both overlap each other in terms of functionality. I was using Hub way before I think the GH tool came out. And for my purposes, Hub is very useful. There's just no need to use the GH tool, but it's cool as well, and you can check that out. Now, one of the cool things that Hub can do is that when we want to create a new project on GitHub, we'll actually go through it now. So the traditional workflow is for me to, I'm guessing, hit the plus button here. We can create a new repository. We can give it a name, so demo repo. We can give it a description, and then we can set it as public and private. We can add a README file, a git ignore, which I'll cover off soon if you guys don't know what that is. And we can even choose a license if that really matters. So let's just add one in, and it's not letting me create it. I don't know why. I've got to take that away. Okay. All right. So there we go. We create a repository. That's all good. Now we've got a repository. Now what we're going to do is we're going to clone it to our local machine. And so for that, there's a variety of methods to do that, and I will cover that off very quickly. And then we can go to wherever we'd like to download our Git file. I'm hoping you guys can see that. I'll just open up a full iTerm window, actually. Go there. Thank you. Yeah, so you can see my shell right now, what I'm typing. Just making sure. So the other thing we can do is we can git clone, and then we can do that. So that's how we, and then we cd to that. So then we go to cd demo repo, and now we're ready to start working. We've got a remote repository on GitHub. We've got a local copy of it on our computer. You know, we can start opening up, you know, a README file, adding in, you know, the description of the repo, etc., all that kind of stuff. So as we saw, there was quite a few steps involved there. So what we're going to do now is we're going to try out a new tool called the Hub tool. Now, what the Hub tool allows us to do is to go hub create demo repo, and we'll call it demo repo 2, just for the example. So that needs to be run in a Git repo. So we're going to go git init. In fact, I'm going to do mkdir demo repo 2. Again, this is not the fastest way But the point is that you don't need to even open your browser at all. So we go Git init, which Git init is the way to create a local Git repository. So Git init. And what Git init does, just for you guys that don't know, it creates a .git folder in your repository. And again, I'll quickly cover off Git init in the later slide. So we've got a Git repository. Now we can do hub create. And now we'll see what happens here. So I don't even think I need to give it a name, but I already did. And so what we can see here, we've just created a new repository on GitHub at this link. So we've done that completely without having to use the browser. So if we visit here, there we go. So that saves us having to do this. Now, even better, we can actually further use a little bit of scripting to automate this. So let's go out of here. And what I'm going to do is go git new repo. Now, this won't work for you until you set up like the shell and the alias and the hub tools. So if you do try it, it'll probably fail unless you set this up, but I will give you the information to get that working. So what we can do is go demo repo 3. And this is going to do a whole bunch of cool stuff. It's going to knit the Git repository. It's going to create a directory. It's going to send it to the remote. It's going to write it, and then it's going to put us in the folder. So we're ready to start working. So in about 1 second and 1 command, so that's the hub tool in a nutshell. It's pretty awesome. It's not something to get started, just as an F1. Next thing that we can do with GitHub is creating an awesome profile. So this is a fun little Git and Git, because you would be creating it with. You can see here, and I'll go to my profile, so github.com/BoWilliams. And we can see here when we visit my profile that there's a few stats. It says, hey there, I'm Bo. Here are some of my stats and my languages and some other cool things. And I think it's really cool to build a little profile site, mainly because it does the work for you in the background of, letting people know, hey, look, this is me, this is what I do, and this is what I'm up to. So the next thing we can do is actually start by creating a new repo. So once you've set up a GitHub account, what you can do is create a new repository. And again, we can just do it through here if we want. And when you're starting out, that might be the easiest way to do it. You can create a new repository, and you can give it the name, and it's a special secret. You give it the name of your profile. So there we are. And I'll actually say you found a secret. Great, we've found an Easter egg on GitHub, essentially. Not really, everyone knows about it, but this is a really cool way to set up your GitHub profile. So all you need to do is write a README file, and so I'll show you what that is going to look like. So in here, and I'll link you guys to the app that I use. I actually use one called README Stats, which is a little repo with some code snippets that you can paste in here. So what we can see is I've put in my description, and these are little HTML elements within the markdown, and they actually have the GitHub stats in there. So that's what displays in my profile here. So that's another cool thing about getting your GitHub profile set up, is you can create a readme.md file in a repository that's given the same name as your username. And then from there, you can put in information, anything you want. You don't even have to use these special little HTML things. You can just write, description about yourself or anything that you want, really. So the next thing is GitHub Pages. So last thing we're going to be covering off with GitHub for now is GitHub Pages. Now, in fact, this site itself is hosted on GitHub Pages, as I mentioned, and it's a free way to host web pages online using GitHub. Now, it's not going to host every single web page you can throw at it. I think perhaps if you built, maybe an app with Python and Flask, that probably won't work. You might need to use something like Heroku for that, or another kind of, PaaS, which is a platform as a service type of thing. But GitHub Pages can host really simple pages from like Jekyll themes to just like a HTML. Or in fact, the tool that I use called Codoc is actually designed to work with GitHub Pages out of the box. So it makes my life very easy. So you can essentially go to a repository. For example, we'll go to the one that we're at now, the Git repository. And in here, there's an index.html, and there's some other stuff going on. And like what we can actually do is go here to the settings, and then right here near the bottom, there's a GitHub Pages. And so you can actually choose the root or the /docs. You can set up a custom domain, all kinds of stuff. But what you end up with is a little site that is hosted on GitHub. You don't need to do anything to deploy it. It basically does it automatically for you. And when you push the changes to your GitHub, which is the remote repository, it's going to be automatically updated. So it's super awesome. And there's a link to some docs in there for you guys that want it. So cloning your first repo is really easy. I'd say the easiest way to get started, if you've never used Git before, is to head to GitHub, find a repository that you want to clone. So for example, you can clone this repository that I made just this morning, which was your first commit. And there's a button here for code. And what you can do is just hit the drop down and you can copy this link. Or in fact, you don't even need to do that. You can actually just copy it straight from here too. And so we'll copy this. I'm going to go to, let's go to a temp directory. Now I'm going to do git clone. And it's going to clone it for us. Now we can cd to this file. So folder, I should say. And there we are. We've got a complete full copy of this remote repository on our local machine. Now, the really cool thing is that we can now start working and making changes and then pushing it back up on the fly. And it's a complete full copy on your machine. It's really awesome. Now, with Hub, you can actually just remember the name and of the repository, but it's not essential, really. Am I lagging, guys? I think it's fixed now. Let me know if I'm lagging. Yeah, okay. All right, fingers crossed we're going to be all good. I'll try and talk slower or something. Maybe that's tripping it up. All right, cool. So I'm just going to quickly cover off for a bit of background. So what actually happens when we clone a repository? Because you might be really interested. So essentially what a Git clone is actually an alias. It's actually an alias to more commands. So one of the interesting things we'll cover off later is writing your own Git aliases. And clone is not a standalone command. It's actually an alias that does about 3 or 4 different commands at once in the background for you. And you wouldn't know that, and I didn't even know that at first. I just thought it was what it was. But it turns out it actually does a lot of more rudimentary things for us. So if we see here, what it actually does is, so if a new local repository is created, Git init, and you actually saw me doing that then. It's then going to configure the remote repo by doing git remote repo at origin, right? And so that's essentially attaching a local copy to the remote copy. That's kind of binding them together. The next thing it's going to do, it's going to fetch all the commits from the remote and put it into your local copy. So you're going to have a full-on local copy of whatever's on the remote repository. And then the last thing is it's actually going to check out, which you might not realize that it does that, but actually checks it out to the master repository. Because when you first initialize or clone a repository, it's not checked out to anything. So it actually has to be checked out to the master, and that happens all in the background. So the next thing we're going to do is start writing our first commit. And for those of you that have used Git, you're definitely going to know how to do that. But for those of you that haven't, you might not know what it is. Now, there's a concept called the staging area, which sounds really complicated. And to be honest, it still sounds complicated to me because I just don't think in terms of that. But what you do when you commit something is essentially put it in the stage, take it out of the staging area and push it. Well, this is before you push it to the repository. So when you commit something, it goes into the staging area. And then eventually, once you're ready with what's in the staging area, you can then push it to the remote repository. So we're going to start by writing a quick commit right now. So I'm going to, again, open up my shell. And we've got this demo repo 3, so perfect. I'm going to just do an echo command. And what this is going to do is just create a new file with some text in it, just so you know. So I'm going to do some text. And then we're going to put it in new.file. Cool. So I've created a new file. And we can see here with my shell, it actually tells me that there's one untracked file. So we can do git status, and it's going to show that there's an untracked file. That's cool. Okay, so we've got this new file, it's untracked. So how do we add it? Well, there we are. It actually tells us right there. So what we can do is go git add new.file. And now we can see there's this plus icon here, +1. So that's saying that we've committed, or sorry, we've added one file to the staging area that is to be committed later. So from there, what we can do is we can then do git commit. And this is a very basic workflow here. And when you're starting out, this is totally how you want to go about doing it. So it's going to load up this commit screen, and you guys won't actually have this unless you've set it up yourself. But again, I'm going to also show you how to set up a commit template later, and it'll be linked in the docs. So we can just say new commit, or I'm going to say adding new.file. Perfect. I'm going to write it. I'm going to quit this. Whoops. And now, and depending on your shell, you won't see that. But essentially, it's saying that we've committed the file to the repository, and now it's waiting to be pushed to the remote. Okay. And so the last thing we can do is just issue git push. And it's going to write the files, and there we go. So let's go and have a look at that. What did we just do? So I'm going to go into my profile again. We're going to look at my repository, demo repo 3, out here. All right, cool. And look, there we are, new file, added 1 minute ago. Perfect. Now, the other cool thing that GitHub allows us to do is very easily view our commit history. Again, you can do it on the shell, but sometimes it's like, why bother? Why bother learning a command when GitHub just makes it so easy? And so here it is. We can see it 2 minutes ago, and we can even get the reference number right here. So that's really awesome stuff. So let's move on to the next thing. So the other thing about Git status or Git log is that you can get different things from that. So let's go like git status. And if you wanted to know the commands, we can go git status -help, right? And so there's a whole bunch of different things it can do, like git status -u, which tells you the untracked files. The other thing is Git Log, which tells you the commit history, so we can see that there. So obviously that's right there. Or we can get a shorthand version of that, Git L, or we can do GL, which is my it's my little alias. All right, so that's done. So we've just written our first commit. Awesome. The next thing we're going to do is figure out, okay, so we've got a new project and we've got all these files in the project. For example, we're making a Java project. And when you make a Java project, or any of you that have made a Java project, you end up with these .class files. And they're not really necessary. They're not really a part of the code. They don't have anything to do, you know, with the logic. They're compilation files. They're kind of just things that are produced when you're trying to run the code. It's bytecode, and it might be machine specific depending on what language you're working with. So you don't want to put that in the remote repository where all the different developers work on it, because it's not necessary being there. The other reason why you might want to ignore files, and again, it's not a recommended way to do it, but if you've got API keys or secrets in your application and you're a one-man developer, maybe 2 developers at most, you could probably use a git ignore to prevent those API keys. So it could be a you know, secret.json, I don't know, whatever it is, and it's got API keys in it, which are like special passwords. You can use the .git ignore to prevent those from being uploaded to the remote repository, because obviously you don't want people seeing your passwords and API keys. So now you could also use environment variables. Again, that's not to hiding secrets because they're not encrypted in transit. So, you know, if you're working for a company and you have DevSecOps guys, they won't let you do that. So environment variables aren't really acceptable either. You should be using a secrets management utility like HashiCorp Vault, but that's way beyond the topic of this discussion. So we can start by creating a git ignore file. And in fact, actually, the best way to do it for certain files that you don't want committed, like say when you're using Vim, you might end up with a .undo file, which records all of the undone changes in your file. It's like a cache, basically. And you don't want that in there. So you can use a global git ignore file to do that. And so we can actually see, I've actually got one set up. And typically on Windows, it'll go into this directory, or on many systems, it'll be automatically placed into .git ignore, which just sits directly in your home folder. So we can see here that I actually already have one. And so the easiest way to configure it, right, is we can actually set one up using this command right here. However, I already have one. And now I can see here, this is where it's located. And I can basically open up nvim or something, and I can edit it right here. Now, say there's a file, as I said, that I don't want ever to be committed into any project ever. Let's say it's called don't.commit. Now, I'm going to make a file. I'm going to save this now. So now we never commit any file that's called this. Now, I won't go into more detail here because there's a lot that goes into the regex patterns involved in setting up your git ignore, but I've got a link to a document that will give you all the templates for all the different languages and things, so don't worry about that. So now we've added this file called don't.commit to our global git ignore. Now what we're going to do, let's test this out. So I might just quickly reload my shell just to make sure that it's the file is sourced, just to be careful. And then I'm going to create a new file called don't.commit. So we're going to go touch don't.commit. All right, so we can see this in here. Now, the really interesting thing is that, have we noticed that I just made a file called don't.commit? And where's our plus icon? Where's our untracked icon? All right, let's go to git status. Interesting. There's nothing there. But we did just create a file, right? So why is that? Well, the reason why is because the .git ignore file is preventing the this one, the don't.commit file, from being committed. Now, I'm not sure, but just for the sake of this, there you go, perfect. So you can't even actually add it. So if you go to do git add, which the dot here is actually single staging error. So we do that, again, it does nothing. So that's setting up a .git ignore. It's really simple, it's really effective, and it's really useful, and it's something that you should learn very soon, especially if you're going to start working on bigger projects. But in the meantime, when you're getting started, don't worry about accidentally committing files you don't want there, because maybe that's an opportunity to learn another thing, which is Git RM. All right, so we've just learned about git ignore. We've just learned about committing and adding. So what about stashing changes? Like what I mentioned earlier about one of the great benefits of Git is what if we need to go and work on another feature? Well, let's get it started. So I'm going to create a new file, touch.stash.me. So now we've got an untracked file, stash.me. Okay, cool. So one of the mistakes I made here, and I guess it doesn't really matter at all, I can do this on the master branch, but generally if you're working with a stash, you're probably going to be working with a branch too. But we'll just do it on the master for now, pretend I'm just a one branch kind of guy. So what I'm going to do is I'm going to do git stash. And what git stash does is, sorry, I'm going to have to commit these files first, my bad. So I'm going to do git add, add the files. And then I'm going to do git stash, git commit dash m, committing some files I plan to stash. Whoops, that's not right. Ignore that. Yeah, so we're going to do git stash. And now what it's done is it's actually saved this stash.me file in the working directory. So now we can see here it's gone. Where did it go? It went into the git stash. So now if we do a git push, nothing is going to happen. Okay, let's do a git commit. There's nothing to commit. So we've removed the file completely. So now we can start working on basically the repo as it was before we made any changes, and then we can start doing things again. Now, the really cool thing about that is that essentially it allows us to go and work on a bug, for example. So we were just working on a feature, and then all of a sudden there's an issue pops up on GitHub, and then we have a bug, and we have to go and fix that right away. So we can stash the current changes. And then once we're finished fixing the bug, we can come back later and we can do this, git stash pop. Something we can do as well. We can actually tab complete, and it's going to find us all of the different stashes. But if you just want to pop the last one, there we are. So it's actually going to put it back. So if we go ls, we're going to see our stash.me file has been returned back to the working directory. So that's a bit about git stashes. Now, obviously, there's a lot of other things you can do with git stash, but I'm not going to go into too much detail. Here's a link to learn more. So branches? Well, branch is important in fork and pull workflow. So the fork and pull workflow essentially now create a branch on that, maybe a feature or something, and then later on you can merge that branch back in. We can see from this diagram how it's all working. So we've got the main trunk is what it's called, and then we've got these branches that come off the side, and then they can be merged back into the main trunk later. So how do we create a new branch? Well, let's go and create one in our repository. So I'm going to go Git Stash to stash that change, and now I'm going to do Git branch, and I'm actually going to use a shorthand way of doing it. This basically creates a branch and checks it out at the same time. I'm going to go Git checkout -b, and then we're going to go new feature. That's what we're going to call our branch. All right, fantastic. So we've got a new feature branch, and we're automatically running the new feature branch. And now the other thing you can do is do Git branch to check which branch you're currently in. It will actually highlight with this little bit. Again, if your shell doesn't tell you that kind of information. So now we're in our new branch. We're going to create our new feature, new dot feature. And so that's done. Great, fantastic. We've got a new feature. So now the next thing we're going to do is we're going to push it and we're going to add it. So I'm going to use this shorthand thing called ACP, and we're going to say make our message committing our new feature. And that's done. All right, so I'm going to show you something really cool that GitHub does here. We're going to go to GitHub. We're going to go to this repository called Your First Commit. And we're going to see this little awesome thing pop up right here. It actually recognizes that we've just pushed a new feature to the new feature branch. And so the awesome thing about Git is that it offers these kinds of really handy little tools and tips that make your life a lot easier. So we can just click compare and pull request. And now we're actually submitting our first pull request, guys. So we can do merging the new feature. I'm going to do create the pull request. And it's going to check if the request can be merged. And then we're going to confirm the merge. Now, one problem that may arise when you're trying to merge a branch is conflicts. Now, conflicts are what happens when you've got two different branches working on the same code and they've made changes to the same code. And so who gets priority? Well, Git doesn't automatically assign priority to any branch. It's up to the developer to make the decision based on what code. And so you can use GitHub to do that for you, to merge the conflicts. I'll give you an interactive interface to do it. I won't go into too much detail because it can be a bit complicated and messy to do. Names quite easily, just like that. So we can go into our branch and we can go and rename it. But again, super easy stuff. I won't bore you guys. So I've already merged some Git branches and I just showed you how to do it. So I won't spend too much time on this. But again, we use the merge and the checkout options using GitHub. And here we go, we can see we can interactively merge a branch. And it'll pop up in here in GitHub, right in your repository. You can compare and pull request, merge it. And the other thing is you can actually close it. So you can block the pull request and say, we don't like that code, it's bad. Or we can comment on it and say, look, it's really good, but it's got some issues. We need to make some changes before we merge it in. You can do all that stuff with GitHub. Now, some people might ask, and I previously asked myself, what is rebasing, right? So the difference between rebasing and merging is that merging is essentially looks like this, right? So you've got the main code, and then you merge some more into it, and it's this continuous pattern of branching, merging, branching, and merging again. Now, what that could potentially lead to is a messy commit history. But I think realistically, that's not really an issue unless you've got very specific reasons for it. Now, what rebasing looks like is that you end up with a single long chain of commit. So you have a single trunk. And this is sometimes what is called trunk-based development workflow. Now, let's see it in action. So I've just got an example here. So what we've done is we've checked out a new feature. We've created a new file. And then we've checked out the master. So we've gone back to the master. And then we've called git rebase. And then we've pushed it to the main repository. And then it's very simple. It's exactly like doing a merge. But again, you just end up with the git commits instead of being squashed into one thing. So you don't end up with this history, which means in the future, you can't go back to these specific states. They get removed essentially. So that is the one real caveat behind rebasing. Now again, why would you want to use it? You get a cleaner commit history and a cleaner project history. Sounds great, right? But why would we want to use merging? Again, it's verbose. Again, why would you use a version control system if you don't really want to track versions of your software much? It can potentially destroy your project or significantly cause you headaches. And again, you might miss out a merge commit history that might be useful later on for debugging and when things go wrong. So it's a trivial benefit, but if you really need it, you can use it. And last but not least, if you really have to rebase, try using the Git Rebase -I. That's an interactive rebase. It'll ask you for every file, do you want to rebase this file? And that's probably, I recommend, maybe the best way to go about doing it. So the other thing about Git and what it enables and why it's so popular is it enables many different workflows and patterns. So the one that I is the for pattern, but there's a whole bunch of other ones such as trunk-based development, like I mentioned before, integration workflows. You can have release branches and tags, and you can have topic branch workflow, and there's many, many, many more. Uncle Bob or Martin Fowler has a great deal of description and of all the different patterns and workflows, so do check that out. I've linked that there. So the fork and pull flow is essentially, the reason why I wanted to bring it up is because this is essentially the way that open source developers work on GitHub. Let's have a look. You go to github.com, and I've actually done this already. So I'm going to go to my repositories. And we've got this project called Hub. So what I've actually done is I've found a project that I think I want to improve, right? So I see this github.hub. Let's say there's a typo in here. This is spelt wrong, or it's the wrong command, and I see an opportunity for me to fix the problem for them. So what I can do is hit the fork button, and it's going to say I've already forked it. You can fork it to your local profile. And then we can see in here that it ends up in our repositories. So it's right here, your first commit. Oh, sorry, that's the wrong one. So it ends up here with the hub repository. Now I can then clone this. So let's go to Z hub because I've already cloned it before, and we've got this branch called bug fix. Awesome. All right, so I'm actually going to change the branch in GitHub right here because I've already pushed some changes to it, and we already know how to push changes now. We can see my branch here, bug fix. Again, this is an awesome reason why GitHub is very useful. So now we can actually see it's one commit ahead of GitHub master. So we've made a change, we've put it on a branch, and now what we're going to do, I'm going to submit this to the GitHub /hub team for them to review it. just like I did before with my own merge changes. And if they accept it, fantastic. You're officially an open source developer who's contributed to a real open source project. And so now I can create a pull request here, which I'm not going to, but I can give it a description of what the issue was, and they'll be able to see the code. And so what they'll actually get, so I'll show a pull request, one that I have received. So here we are. This is perfect. So I can't find, interesting. I can't find my own ones, but they're all, that's all fine, whatever. So here's one that I submitted. So we can see here in the pull requests that there's 12 closed, and this was the one. Oh well, I can't see it right now, but we get the point. And I'm wary of time, so I'm going to move on. But the Git workflow with the fork and pull is essentially the #1 way to work on an open source project. So that's what's called committing your first PR on GitHub. So again, uh, they're all done. Give you an example right now of how it works. So if I go to my notifications section in here, I've actually got this notification that came in 3 days ago, and it's a security alert. So essentially it's saying, hey, look, there's been a published vulnerability on one of my dependencies in my portfolio. So that's all good. What I'm going to do is I'm going to actually go to this branch here, and it's actually automatically created a pull request for us and a branch. And I can click on this. It's going to tell us what the issue was. So it's going to say it's bumping the version of Elliptic from 6.5.2 to 6.5.4. It's going to give us an option to merge the pull request. We can hit confirm merge, and it's going to do it, and then that's it. So let's go back to our portfolio, and we can see here we've bumped up the Elliptic version in our yarn.log. So we've just fixed a security alert. We didn't have to do anything. It came in as a notification on our profile, and that's it. All right, so the next thing we're going to do, here's an option to look at the differences, and I won't cover that off, but please follow through afterwards if you'd like. We can also remove files from Git. So I realize it's about 3:05 now. This is actually taking a lot longer than I expected, but that's all good. So now removing files from Git, here's an instruction for doing it. Now, the caveat and my piece of advice is if you ever commit a file to GitHub that's sensitive, like say a password or something, just go and change the password, because it's going to be a lot easier for you than having to, essentially go through this whole process right here, which is quite complicated. But it is a bit of good practice. The next thing you can do is revert your commits. So again, you make a mistake, you want to revert it. What you can do is just do git reset hard and get the ID of the commit. So you can come here in GitHub, and we can go to our repository. We can go to our first commit file. We can go to our 7 commits. Say the one our merge request was wrong. We can copy this, right? And then we can do git reset hard, and whoops, that's not it. Git reset hard, and then we can reset it to this commit. And then that's it. I don't know why that didn't work. What did I do wrong? That should have worked. Oh, well, it doesn't matter. The point is that you can reset to a previous commit, and you can get those commits from GitHub. And then once you're done, you can just do a git push force, and that's going to overwrite the remote copy and essentially remove the last commit. There's also some other options. So the other thing is your Git originally. So when you set it up, needs all configurations. It's also going to show us what file is actually setting up this configuration, where that is stored. That's really handy to know. So commit templates are really awesome. Now I'm going to show you what a commit template looks like right now. So I'm going to do touch commit.new, just like a new file. And then I'm going to do git add dot, and then I'm going to do git commit. Now what pops up here is we get this awesome little thing that's going to offer us all of these little suggestions. It's going to help us format it with a body, and it's going to help us format it with a footer. Now, every time we write a commit, we're going to get this thing popping up, and it's really awesome because it allows us to write very professional commits like this one right here, where it's got a heading, it's got a body, and it's got a tag or some kind of little bit of information, such as it resolved issue number 42. So the code's right here, and you can set it up, and essentially you just do it by configuring your git config again. So right here is where you do it, and it's the commit.template, and then you set the path to the file. It's very easy. So the other thing we can do is create shortcuts, and you might have seen me using some, like the git new repo command that I made, or the ACP, which adds, commits, and pushes all at once. Or the GP command that I wrote will push to the remote repository and also link it up if it hasn't been already. So that's another great little thing that you can do with GitHub. So backing up your configuration files, that is another really awesome use for GitHub, and something I really do recommend, because I have lost my configuration files in the past due to stupid mistakes. And it's a pain in the ass to have to go and make them again. So we can, for example, like I do, I just create a bash file, and then I call it in my shell, just like that. And so I can go in here, and then say I want to merge my cheat sheets, I can do that. And then I go to my .files folder, and we can see them in there, and then I can commit new updates to configs. And there we are. That's going to back them up, and they're going to end up right here in my .files folder, which I can find right here. So perfect. We're going to see that they've been backed up right here in my cheat sheets folder. So that's going to make sure that they're all kept there and that they're not lost ever. So really awesome stuff. So the next thing we can do with GitHub is sponsor open source projects. So for example, I sponsor the NeoVim project. I'm very bullish on NeoVim. I think it's doing wonderful things, and I just want to help contribute. So we can actually go to GitHub, and if you ever find a project that you just really love, say you really love the Hub tool, so we can go Hub CLI tool, and we really love it, and we really want to support it, we can actually sponsor it right there, and they actually don't take sponsorship. So that's a really funny example. So I'll go to NeoVim and search for GitHub. There we are. We can go here, and there's actually a sponsor icon right here, and we can follow through and you know, say sponsor them for $2 a month or something like that. So that's something I really recommend you do. It's really great to support open source projects, and it's going to come under here as sponsoring, and it's going to say that you're a GitHub sponsor. So that's a really cool little thing for your profile as well. Now, there's a bunch of handy commands here. Won't go through the details, but thank you so much for listening to my workshop. I really hope you guys have learned something. I didn't realize that an hour would go so fast. I actually had a lot more things I wanted to cover off, but the time's gone really quick. So I do appreciate that you all have the rest of your day to get on with things. So what I'm going to do now, I'm actually going to start a quiz on Git. So for some of you that maybe do or don't know Git, I hope you all do really well. But let's get started. For the top 3 winners of this quiz, you're going to score a Google Home. So let's get into it. I won't delay any more time because this, this hour's just gone super, super quick, way quicker than I expected. So here's the link. Here's the link here. So the code is, put it in the chat. And so you can just get started signing up now, and then we'll start the quiz once everyone's on. Is there any questions, just by the way, any specific questions you guys have about what I just went through? Do let me know. Happy to answer. Do the quiz. I know this website posted on GitHub Pages. This is a good site. If you're ever going to run a quiz, I highly recommend using. It's the same as Kahoot, but it's a bit better. I think you can have more people, and they put memes in there without you having to do anything, and everyone likes memes. So. All right, so is everyone in now? Let me see. Just let me know if you're having trouble getting in. I'll just leave it for maybe 1 more minute, and then we'll get started. All right, so I think this might be everyone now. You ready? Let's get into it. So good luck, everyone. There's some good questions in here, and I wish you all the best. Hey, Lynn. Please. Okay. All right, guys. So is everyone done now? Let me know if you're not yet finished. If so, looks like we might have some winners. So I believe Andrew, Chi, and Ewan. You guys were the winners. So send me an email. With your details, just like an address and where to send a Google Home to, and I'll get them sent off. I'll get in touch with Matt at Google, and I'll get him to send it off ASAP. So congratulations, guys. That's fantastic. And now one more thing I'm going to do before we finish is the lucky draw for some of you who attended. I'm also going to throw out some Uber Eats vouchers. So that should be super cool. Let's get it started. All very close. All right, so BJ, you're going to win an Uber Eats voucher. So who's next? Let's see. I'm going to remove that name from the pool. That's a bit unfair. Yeah, you can't win twice. No. All right, let me remove the name. Yeah, here we are. We'll shuffle it and we'll run it again. That's a buoy. That is one for you as well. And last but not least, shuffle it again. I'm going to run it once more. All right. Ewan, lucky day. Yeah, so I just got a direct message from Andrew. So just let me know your name, and send that to me in an email. Again, it's at bo.williams@icloud.com. I believe that should be all that I will need. So thanks so much, everyone, for coming. I mean, honestly, like, I wish I could have covered off more during the during this workshop than I could. There's so much more to learn with Git. I put in a lot of effort into these docs, and I really hope that there's some really handy little commands, some things in there, so you can actually find it directly on my GitHub profile right here. So I'll put the link in, and you can also follow me on GitHub there if you want. Sorry, I'd send that to the wrong person. You can also follow me on GitHub as well. So that's another great way to keep track of your friends at university. You can follow them on GitHub, and then you guys can see what each other's working on and support it and stuff like that. So again, thanks so much for coming. So just send me an email to my email address with those details for those of you that were winners, and then I will get that sent out right away. So with that said, is there any specific questions that any of you guys have, or would you like to, I guess, follow up with me at another time? That's up to you. but I've lost my Zoom window now, so I don't know what's going on. Here we are. That's great, BJ. I'm glad you learnt a lot. There's definitely there's so much that goes into Git, and I think it's a really cool little tool. And honestly, if multiple people work on a project in GitHub, who owns the copyright? That's a really good question. Depending on the license, that will be different. So depending on the license again, so if you use an MIT license or the GPL license, there's no one has copyright ownership because you're effectively, it's a license that gives away ownership with terms and conditions. So the GPL license means that you have to again release your software as open source in the future. MIT is the favored license for closed source, not as in closed source companies use it, but they love open source projects that use MIT. For example, the Apple operating system is heavily built on the FreeBSD and the Mark architecture. So that's called the Darwin kernel. And the reason why that they can do that is because Mark and BSD is based on the MIT license, which means that it's completely free for anyone to take that software, go and use it, they can resell it, they can do whatever they want. So as a roundabout way of answering your question, I guess it gets complicated. I'm assuming that if you were to write a license that would close off the source, that would mean that essentially the owner of the GitHub repository probably claims ownership. I actually think you need to put your name in the license. So it would be, say, license to Bo Williams, and it would have to be in the license itself. I don't know if I'm the best person to ask though, but that's what I know. No worries. I'm glad that you learned something in terms of a real scenario. In fact, that was my plan, to kind of just work through just, creating your first pull request, because that sounds like it sounds, when they say create a pull request, it sounds really crazy and complicated, but it's actually with GitHub, it's literally, you can click a few buttons and you get there. And the combination of Git and GitHub is really awesome. So I just wanted to show off a bit of those tricks. There's a whole lot of other stuff it does. It's really awesome. I'll just show one last trick before I shut this off. So I'm going to go to one of my repositories, and this is a repository that real people use. So I can see here my statusline.lua. I actually have one called focus.nvim. And so I get issues in here. So I actually did have an issue not long ago. And they said they wanted, here you go, it introduces a bug. These are actually my one. Add an option to disable cursor line by default. And so this issue is actually number 4. So the amazing thing we can do here is if this issue was open, I can actually go into GitHub. I can go to first commit, and let's just pretend we're touch new file. I'm just trying to do this fast so I don't keep you guys waiting. So what we can actually do is we can fix this issue directly from the CLI through the commit flag. So if I go ACP and I go fix number 5, now if we had an open issue that was number 5, what would happen is it would actually automatically close this for us. It'd put this in here and say that's the commit relating to this, and it actually adds a reference in there and it closes it off automatically for you. So you don't even need to go onto GitHub. You just put in your commit, close issue number 5, it closes it off, it references it, it puts it all in there, it notifies the person that made the issue. It's fully automated. It's really awesome. That's another great thing when you're actually working on a real project. You get a lot of issues. That's really handy as well. So that's it for today. It's time is it? It's like 3:30. My God. All right. I'm going to go have a break. You guys have. Thank you so much for coming. Again, send me your email address and details. BJ, you sent me that there. I'm going to try and copy it. I really don't. I'm going to stop sharing my screen, actually. Obviously, I don't want to expose your information on there. But that's it. So I hope everyone has a really great afternoon. Thank you so much for coming. And yeah, feel free to follow up with me. Yeah, we're going to do more cool things with DSC in the future. Again, any of you are looking to lead a club, let me know, let us know, and we're happy to get you set up. Have a really good weekend. And again, let me know you have a good afternoon, and you guys there.